Okay, hello, we are the Dynamite Duelers, and this is our project, AI Animal Prediction.
Here's a brief summary of our project. The main goal of our project is to take an inputted image and output the animal's name and description. The animal's name is displayed in the bounding boxes as shown in the image to the right. These bounding boxes also include a number which is interpreted as the AI's confidence in its prediction. After the prediction has been made, the AI system also outputs the description of the animal. This description includes the animal's endangerment status and some other facts about it. The goal of the description is to help raise awareness to endangered animals and to educate people about the animals that they input. The accepted animals are alligators, bears, cats, cows, dogs, elephants, horses, lions, lizards, monkeys, pandas, pigs, sheep, zebras, birds, and tigers.
So as a group, we all have a really strong liking for animals, so therefore we wanted to integrate that into our product. It is important to spread awareness of endangered animals as well, so we decided to include it. Additionally, having this component makes it a better product in terms of usefulness. Ways of using the software could be via drones when needing to determine an animal's endangerment status, or if someone is simply hiking or doing an outdoor activity and they see an animal and want to know if it's endangered or not, or simply just gain more information on it.
Here are some of the resources that we use while developing our model. So first, we utilize CoCalc for the majority of our programming and training the AI. We use both CPU and GPU servers while making this project. When our CoCalc servers were down, we would use Google Colab for additional training on the model. We use Kaggle to gather images for our dataset. And in addition, we use SERP API to web scrape images for the dataset. And we use Roboflow to compile all of our images and finalize the multiple versions of the dataset. And we use weights and biases to monitor the training performance of our model.
So this is the summary of our process. We're going to detail our process in the following slides. So first, we found images based on our chosen 15 species from Kaggle and web scraping. And then we used Roboflow to annotate and label the species of animal in each image. Then we utilized CoCalc for our programming of our AI. Then we used weights and biases and tested our images and evaluated the data and took notes on the potential roadblocks on the confusion matrices. And finally, using the data, we eliminated potential roadblocks to improve confidence for identifying our species of animals.
So for step one, we decided on 15 species of animals that we are going to use. Once this was done, we had to start uploading images to Roboflow. Our goal for each species was to have around 500 images, so in total around 7,500 images. Because we needed so many, it wouldn't make sense to get each image individually from Google and uploading it, so in result we used two methods, Kaggle and web scraping. Most of us used method one, Kaggle, a website that offers datasets. For most of our animals, we were able to find pre-made datasets on this website, although some of us did use method two, web scraping. Via this method, we coded our own web scraper on CoCalc. This would essentially do the manual process of finding images on Google for us and would then compile the images into a dataset. Although this method was effective, we found that some of the images that would appear in these datasets were cartoons, drawings, or just invalid images.
Roboflow is an online tool that processes images and helps annotate them. We use Roboflow to annotate our images by dividing the data and assigning each person a couple animals to annotate. For example, somebody would do cats, bears, and dogs. We also uploaded the images to Roboflow in separate animals, which were created jobs for the person to do. The person would then select the job and identify the animal in each image with the box of the color associated with the animal, which the person would have to set. For example, if the image was being annotated was a cat, then the annotator would draw a large pink box with the label cat around the cat in the image. Once everybody had finished their animals, we combined all the images into one large dataset, 80% of which was used for training, 10% as valid, and 10% as test. This is a GIF that shows how we draw the boxes around the subject. In this case, we're annotating a sheep.
So we used CoCalc to program the AI. We use CoCalc. CoCalc is the platform that we use to program multiple parts of the project, including training the model, creating our website, and performing other backend tasks to get the AI running. On the right side, you can see some of our programming in CoCalc. We use both CPU and GPU servers. The GPU server was used primarily to train the model, and the CPU server was primarily used to make the website and connect the model to the website. When our CoCalc servers were down, we would use Google Colab. There was additional training for the model on Colab.
Here you can see our different confusion matrices for our different versions. In the one on the right, you can see that we have both crocodiles and alligators. We ended up removing crocodiles because the AI was confusing them with alligators. You can also see that lizards have a very low success rate, and that's due to the fact that they blend in with camouflage quite well, which is one of the main reasons that it didn't detect well. And in some labeling versus predictions, the AI mostly gets it correct, except for the baby tigers in the last image on the bottom middle photo. It doesn't get the baby tigers as they are too small, or it gets mixed up with the larger tiger.
We tried eliminating previous roadblocks by adding more image-specific classes that needed them. We removed data sets that we believed, weren't fit. We tried different methods of augmentation. We tried different sizes of data sets and annotating more precisely. And that's the data we used.
So one of our first challenges was that some animals were extremely accurate, whereas others had less than 50% accuracy. So therefore, our solution was to continuously modify our data set by adding and deleting images, improving the class balance, and by giving more precise annotations. And as mentioned before, one of our challenges was with the alligators and crocodiles. The confusion matrix depicted that these two animals were conflicting. We tried adding more photos to each of their data sets, but ultimately we just had to eliminate the crocodile class. And additionally, the challenge was that our Colab and CoCalc servers were crashing. So in order to fix this, our instructor helped us, but we also noticed that one of our versions had a very large data set. To be specific, it was around 29,000 images because we are using splitting for augmentation. So we decreased the size of our data set to about 7,500, like the original. And then lastly, when it came time to code our product website using HTML, we had issues with the alignment of our text, specifically on our results page. So in overcoming this roadblock, we did research on how to fix our problem, and ultimately we found a solution.
So for our results, in total, we generated 6 versions of our dataset. The majority of the animals were successfully identified, but the AI still had trouble with some animals, such as alligators, crocodiles, and sheep. In our latest version of the dataset, we had 7,521 images. After inputting an image into our website, a bounding box surrounds the animal, says the animal name, confidence level, and description. For each animal, it has a description that includes its average weight/size, their habitat, where they are found in the world, diet, and relationship with humans.
For the future, if we had more time, we would have added a lot more images to the data set so that we can improve accuracy and use a larger model to, again, increase accuracy, but that would have taken longer to train. Experimented with different augmentation methods. As you heard earlier, we have done resizing and splitting. And finally, detecting multiple types of animals in a single image and outputting the description for each. And now I will give a web demo. So this is the main page, which was done from scratch. And I'm just going to upload an image here, and it will show the confidence level as well as a bounding box around the animal. with a description at the bottom for each animal. And as you scroll through, you can see the different portions like our system, what it does, the resources we use like CoCalc and Colab, our process, the challenges we encountered, and finally the about us.